Alrighty, in this video, we are going to be talking about L'Hopital's rule in terms of limits. Thinking back about what we did back at the very beginning of the semester, Unit 1, where we talked about limits. Remember that one of the properties of taking a limit is taking the limit of the numerator, taking the limit of the denominator, and then calling it a day, and then seeing what the two ratios are. Now, here's the thing. If you get 0 over 0, or you get infinity over infinity, they are indeterminate, meaning that we don't necessarily know what it is. 0 over 0 does not mean that the answer is 0, and infinity over infinity does not mean that the answer is 1. Now, you must show that the limit of the numerator and denominator are both 0 or are both infinity. We'll also see later on, it could be either infinity times 0, infinity minus infinity, 1 to the infinity, 0 to the 0 power, infinity to the 0 power. But in this video, we will only focus on 0 over 0 and infinity over infinity. So we have to show that the numerator and the denominator is 0. And here's the thing. We cannot write, do not write the limit as x approaches whatever value you are evaluating of f of x over g of x is equal to 0 over 0, and then use L'Hopital's. They will not give you credit for it. So please do not write that. Instead, follow my steps on what to do in terms of these types of problems. Number one, hopefully you already know what this limit is, because back in pre-calc and back in the very first unit, we talked about how this limit was one using a table and using graphs. So now we are going to see how we could do it algebraically in terms of L'Hopital's. So what I'm going to do first is take the limit of the numerator. The limit of sine of x as x approaches 0 is going to be 0. And then I'm going to take the limit of the denominator, and that's 0. Since we have 0 over 0, this is indeterminate form. We can use L'Hopital's. This is what you should write on the FRQ if by chance you get an FRQ on L'Hopital's. Now, I haven't explicitly told you what L'Hopital's rule is right here, but essentially, once you get 0 over 0, you're going to take the derivative of the numerator, and you're going to take the derivative of the denominator, and then see if we can evaluate it. Here, if I were to use direct substitution with cosine and 1, obviously, the limit as x approaches 0 of cosine is going to be 1. So we get 1 over 1, which is just 1. Because this is not an indeterminate form, we are good. So your limit here is 1. All right. Same thing here for number 2. What you're going to do is take the limit of the numerator. So you're going to substitute that in. You're going to have 3 times 0 minus sine of 0. We know that sine of 0 is 0. 0 minus 0 is 0. And then the limit of the denominator, which is 0. Because we have 0 over 0, it is indeterminate. So that means that we could use L'Hopital's, meaning that we could take the derivative of the numerator and denominator, and then see if we can use direct substitution there. So that's going to give us 3 minus cosine of x over 1. If I were to use direct substitution with cosine, we know that cosine of 0 is 1. So 3 minus 1 is 2. 2 over 1 is 2. All right. So let's look at number 4. Once again, I need to see if I could use L'Hopital's by evaluating the numerator first and then the denominator. So here we have 0 minus sine of 0. Sine of 0 is 0. So 0 minus 0 is 0. And then we have x cubed, which is just going to be 0. Since we have 0 over 0, we could use, once again, L'Hopital's. So I'm going to take the derivative, and that's going to be 1 minus cosine of x over 3x squared. All right, now once you use direct substitution here, you're going to see that I have 1 minus cosine of 0, which is just going to be 1. So I have 1 minus 1, which is 0. And then 3x squared, that limit's going to be 0. So you're going to have 0 over 0, which means that it's indeterminate. Now, since it's indeterminate, you're going to have to use L'Hopital's rule again, meaning you have to explicitly show, once again, that your numerator and your denominator is 0, or else you will not receive credit. So once you do that, you could say, hey, we can use L'Hopital's again and see if we can use direct substitution after we use L'Hopital's for the second time. All right, so now using L'Hopital's for the second time, we have the derivative of 1 minus cosine of x just being sine of x over 6x. Well, sine of x is 0, and then 6x is going to be 0. So once again, plot twist, you're going to have to do this for a third time. And once again, you're going to have to rewrite the numerator and the denominator, or you will not get credit. And I'm running out of space, which is not good, because if I'm running out of space, you're also running out of space. Whew. Okay, one more time. So the limit as x approaches 0 of, let's see, the derivative of sine is going to be cosine, and then the derivative of 6x is going to be 6. Thank Buddha, thank God, because we know that cosine of 0 is going to be 1, and then 6 is just 6. So once you do direct substitution here, your answer for number 4 is going to be 1/6. Crazy, I know. All right, let's go ahead and do 7. For number 7, you could do two things. You can use direct substitution and see that it's 0 over 0 and then use L'Hopital's, or you could use basic factoring and solve it that way. Because if you were to do that, you'll get x plus 1 over x, and then that limit right there is going to be 2 over 1 or 2. And now, if you choose to go to the L'Hopital's route, which honestly I would not encourage you to do it because factoring was easy peasy lemon squeezy. But here, go ahead and show that your numerator and your denominator both approach 0 or infinity. And then L'Hopital's. So then you could say the limit as x approaches 1 of 2x over 2x minus 1. And then if I were to do that, I'm going to get direct substitution of 2 over 2 minus 1, which is 2 over 1, or 2. So either way, for this answer, you're going to get 2. Now, pay careful attention to if you could use L'Hopital's or not. So make sure that you use direct substitution and see if it works or not. This one, number 8, this one's trying to trick you, because guess what? Your x value, you are approaching 1. If you are using direct substitution, that's your answer right there. Nothing too hard about that. I don't know what cosine of 1 is, but we definitely know for sure that it's definitely not 1. So I know that number 8, if I were to use direct substitution, you're going to get that. Same thing with number 10. Use direct substitution. So you're going to get 4 minus 4. and then 4 squared plus 4. Oops, not 4 squared, 2 squared plus 4, which is going to be 0 over 8. Now, 0 over 8 is not indeterminate. You have an 8 at the bottom. That's okay. Even though you have an 8 at the bottom, 0 over 8 is going to give you a limit of 0. So make sure that you also understand that if you have something 0 over some other number that's not 0, that's not indeterminate. That's just 0. All right. And then so far we've talked about limits in terms of 0 over 0. Now what happens like number 6 where we have limits where it approaches infinity and infinity. So notice how here, as we approach ln of x, as x approaches infinity of ln of x, remember that ln of x looks something like that. That's going to be infinity. And then as we do x, same thing here, that's also going to be infinity. So we have indeterminate form. Since it's indeterminate, we can use L'Hopital's. Yay. All right, so once we use L'Hopital's, we have 1 over x over 1. So this is essentially going to be the limit as x approaches infinity of 1 over x. Now, this is the part where we have to use common sense and where we have to use our logical thinking skills on what 1 over x looks like. So this is like your math 3 stuff. As I look at this, and as I approach positive infinity, your limit is going to approach 0. So this thing right here is going to be 0. Okay, let's see something like number 17 here. As the limit as x approaches infinity of e to the x over x squared, once again, you want to see that this is going to be 0, not 0, infinity, just because it's an exponential function. And then you have this right here, x squared, which is also infinity. So you use L'Hopital's. Now, once you use L'Hopital's, you're going to see that you have e to the x over 2x, which means that you're going to have to use L'Hopital's again. And then you're going to have e to the x over 2. Now, I want you to think about this in terms of the 2. The 2 doesn't really matter. I don't care what this is because guess what? This is the same thing as 1/2 e to the x. If I shrink it by 1/2, it's not going to do much. You still have an exponential function. It's still going to look something like this. Because it's still going to look something like that, your answer here is going to be infinity.